Welcome back. We're moving on, talking waves, talking interference, superposition of waves. Let's see. Now here we just want to look at light and see light as having a wave nature. And what are those things that tells us that light display a wave character? One, diffraction. This is the bending of waves around the edges of an obstacle. So diffraction is a property of waves, okay, of waves. So any quantity that displays diffraction should be classified as a quantity that has a wave nature. Okay, let's proceed. When light passes through a small slit, it bends around the edges of that slit. Now, what is bending of waves around obstacles or edges of obstacles? That is called diffraction. And therefore, if light is able to bend around edges of such obstacles, we can therefore say that light has got a wave nature. Okay, wave nature. Light of the same frequency is called monochromatic light. Now already we're talking frequency. When we proceed with this lesson on waves, later on you would see that we have the frequency, we have the period, we have got the speed of the wave, okay, we've got the wavelengths and all those other things. Now already now here we're seeing that light has got frequency, and if light is of the same frequency, we call it a monochromatic light. Okay, continuing talking about light as a wave. When the size of the slit is increased, the amount of diffraction becomes less. Okay, so it means the size of slit, which is usually given the symbol A or D, okay, is inversely proportional to the amount of diffraction. So allow me to use an angle as the amount of diffraction, how much diffraction has occurred on that light. So the size of the slit is inversely proportional to the amount of diffraction. Okay, when the wavelength is increased, now look at the wavelength, this is another quantity. When this one is increased, the amount of diffraction increases as well. So we can say that there is a direct relationship here. We can say that wavelength is directly proportional to the amount of diffraction represented by the angle there. Okay, right. Now, thus the amount of diffraction is proportional to the wavelength of light and inversely proportional to the size of the slit. So if you want to make the diffraction less, make sure you reduce the size of the slit. If you want to make it big, if you want to make the amount of this diffraction less, increase the size of the slit. If you decrease the size of the slit, you're going to make the amount of the diffraction bigger. Okay? Now, moving on, light has the following properties. Let's just have a look at it. It undergoes diffraction, as we have seen. It can also undergo interference, because we have just seen previously that when we're looking at waves, when waves interfere with each other, they lead into interference, which is either going to have destructive interference or constructive interference happening. Okay? So that also happens with light. Okay? Now, if that happens with light, we can say that light displays a wave nature. Okay? Now, just having a look at one of the slits we're talking about. Here, we're looking at waves, light waves. So this is light waves. Looking at light waves, okay, moving in that direction. Here we've got an obstacle, and we've got our slit, okay, that opening. When these waves get through there, they bend around the edges of the slit. That bending is called diffraction. Okay? Diffraction. So we see light undergoing diffraction, and therefore light has got a wave nature. Light has a wave nature because we see it here undergoing diffraction. Okay, so as that diffraction takes place, as you can see, there are the light waves bending around that obstacle. You can have more and more happening like that. Okay, so this tells us that light has a wave nature, and from this we can be able to say we can use the properties of waves to explain what the behavior of light. Right. See you in the next section.